Good morning. We're at the top of the hour, but as usual, people straggle in after a couple minutes. So I apologize if it's really early in your time zone while we wait for a couple more minutes for people to appear. Thanks.
Hey, Sean, could you say something just to verify the audio?
Testing, testing, testing.
Awesomeness. Thank you.
All right, cool. We'll give it 2 more minutes and then we'll jump in.
Meetecho is having some problems for both Conrad and I. It took a really long time to log in.
Sometimes you got to log into the data tracker to get in, so it takes the automatic attendance, etc. So there might be something with the data tracker. But the important thing is you're here now. Okay, it's 5 after. It's probably time to start getting this show on the road. Hi, I'm Sean. Nick is here as well. We're the chairs of the MLS working group in the IETF. This is our first interim in a long, long time, and the first interim of 2024. Just kind of running through the generic kind of IETF slides to make sure that everybody remembers them. So there's a note. Well, since this is an official meeting of the IETF, there's a bunch of rules and things that you need to follow. Probably an important one is that we kind of don't harass each other. This working group has been great. If you have any questions about any of those, do let me know. The other really important one is about IPRs. If you know something, say something. We can help you submit disclosures, etc. And then there's some additional things about meetings, and we try to maintain good behavior as we go, as we work and collaborate. That's really it from the intro slides. The agenda here is going to be pretty free flowing. There's some things we have to discuss about the recharter. The ISG has some comments on the proposed charter. We need to see what we can say anything about the outstanding architecture comments to get that done, because it's kind of blocking the recharter at this point. And then we're going to try to talk about extensions, the extensions galore, as I like to call it, because we got a lot to talk about. So unless there's anybody else wants to add anything, let me know. When we get to the extension part, what I'll try to do is we'll try to frame the whole discussion and then see if anybody wants to say anything about a particular extension, because I know that there was some chatter on the list about some new ones that might come in and others that have been around for a while, and try to figure out how we can get the work going and get the extension work actually done. All right, does that sound good?
Yep.
Awesome. Thanks, Benjamin. All right, so let's get on to stop sharing this screen, and now I'm going to share this screen. Which one? I'm going to accept this, and then I'm going to pick this one. So as you might remember, we submitted our charter text, and it had a lot of history, and basically all we did was change some verb tense. Well, we got 2 comments from the ISG that said, hey, a lot less of that history. We don't really need all that. So my response back is, great, we'll just cut all the history. So now the document, the charter, is pretty short. And all it really says is, we're going to maintain the protocol, and then we're going to work on extensions, which is really what we're going to do anyways. And then it basically just lists all the extensions we had. And then one of the other comments was, somebody said, well, you could technically read the last paragraph there that said internet drafts and imply that we were never going to publish any of them. And I don't think that's the case. So I put separate specifications to kind of answer that. I know that many of you might not really care about the minutia of the process going on. Is there anybody that objects to this kind of approach where we're just like, all right, we're going to work on the extensions? The previous charter exists. It's findable. If people want to read the history about what happened, it's there. Does anybody really object with me just kind of trying to get this done?
Yeah, I don't object to the overall approach. I think the one paragraph I would keep is just the first one that says what we're doing here. It just kind of sets the context.
Yeah, okay. I can do that. I don't want to do this in real time. That would be embarrassing for me. Anybody else? All right, I'll take that as done. Okay, so the next thing to look at is the stuff from Roman. So I want to thank Benjamin and everyone else who went through a bunch of the comments. So the first thing I think that we should probably talk about is the big open issue one, which is, can I just kind of pull that out into another window? Yep. Okay, cool. Let me share this one.
Sorry, which are we talking about, the architecture now?
Yeah, I moved on to the architecture. I think we're pretty much done with it. The other one, I think it's this one. So the one open issue I think that we really kind of need to discuss is this recommended for encrypted group operations. So this is where there's this recommendation, and I think Ecker is basically kind of saying, that like Mimi's doing one thing and we're suggesting something else, and it's kind of not really in alignment. And if you kind of go through the rest of the discussion, Rowan did a good job suggesting something, but then Ecker basically said, this sounds like it's kind of wishy-washy. So I guess I'm trying to feel what everyone else's opinion is on this, and if there's some way we can drive this to closure.
To recap, I think that basically we don't have like, Ecker seems to assume that basically we have like only Mimi as a use case, and that a recommendation should not conflict with the only one standard we have. I disagree. I think that the general way of doing this is that I think we all agree that if we can, we should actually encrypt operations, and if there are use cases where you can't, and that's fine. I don't see that as a problem, to be honest. Like we can't foresee all use cases of MLS requiring not being encrypted. So I would say we just like add the recommendation, and maybe we can caveat it a bit, say, add the sentence saying, say, in the few cases where you actually can't get the functionality you need by encrypting group operations, don't. But take precautions.
So I think that's the way out of this, because typically if you say like, because we're not using 2119 language here because this is an informational document. If you were to make it 2119 language and say should, usually we'd say why you wouldn't do that. So I would think that if you did that, that might address the comment. But Richard?
Yeah, I mean, I'm sympathetic that it feels morally right to recommend doing the confidential thing here. But the thing I think stands in tension is not just Mimi, but empirically the other deployments of MLS that are out there. So the one I'm obviously most aware of is WebEx, which does not use encrypted group operations. I believe some of the others, and it would be good to hear from like Rowan here, who I believe is in the process of deploying, are not encrypting group operations, particularly commits, so that the server in the middle can cache the tree for performance. So I think the idea, the fact that, in practice, people are not encrypting group operations for reasons of scale kind of argues against a real strong recommendation here. But yeah, maybe we could split the difference here by saying, yes, the morally right thing to do is to encrypt the group operations, but there's some compelling reasons not to. For example, having servers cache information about the group.
Note, if I may, that we actually can encrypt and get the same functionality, right? It's just the cost is higher because you need to add an additional encryption to leak special public information to the server. So we could do that, right? But it's just costly.
Yeah, well, and there's no specified mechanism for that. You would have to invent one.
So it's just add the warning and say, like maybe Sean, you can help me phrase this so that it actually is the right phrasing. But
from my perspective, this is more. It's not like you could get away with not doing this. It's that like architecturally, a lot of people chose to have the intermediaries involved so that they could be involved in an authorization kinds of decisions, so that they could be examining the commits and saying, oh, like I like this commit, that looks fine, or I don't like this commit. But there's also, as you described, like there are different ways that you can get information up to the, to one of the providers. You could encrypt it directly to them, right? But there are also different ways that you could provide this metadata privacy, which is you could have everybody use, pseudonym style identifiers or like temporary or ephemeral identifiers, and then only in the group do you share their actual identities. So I think we want to capture what is the actual property that we are protecting, and say if you need this property, then you should protect it by using private message. If you don't have this property and you're doing, and you need some other functionality, then you can go do this the other way. I don't know exactly how to phrase that, but that's what I think we need.
Yeah, the reason I phrased it in that direction is because we don't know. We know what doesn't leak if we actually encrypt it. We don't know what does leak and how to protect it if we do the reverse thing, right? You might actually need leak much more than we actually anticipate. I don't know. Maybe, you know, based on the signatures, people can just so there is a signature, I guess, but there is potential. You know, right now we don't have like extensions to those messages. We don't have like custom MLS messages, stuff like this. I don't know how this is going to evolve. So I would always go back to the safe way, the safe road, the one we know.
Yeah. So in terms of any implementer that's actually doing private message, I can think of one person that has a non instant messaging or audio video application that might be doing this. If there's anybody on the call that wants to speak up about an application that an implementation that's actually using private message for commits.
That's reversing the burden of proof here. You need to prove that no one is going to do it.
No, I mean, it would be very straightforward if there's somebody that's already doing it to just speak up, right?
So I'm working with a client that's using encrypted group operations.
Okay. Can you share any context or like how the decision was made or like what the trade-offs were?
Well, the decision is that it's a decentralized network. So there is not a centralized provider to enforce that.
Mm-hmm. Okay. Yeah. Makes sense.
Yeah, I mean, I think the paragraph I would probably write here, and again, I haven't looked at the text, is something, it's just to highlight the trade-off. Like on the one hand, if you use private messaging, you get confidentiality of everything that's in the handshake messages against the intermediaries. On the other hand, you lose the ability for these intermediaries to contribute, and that impacts your ability to do certain scaling things and to have intermediaries enforce things like authorization, like Ron mentioned.
If you don't have an extension that actually provides that information.
Yeah, I mean, there's like obviously future engineering can change either of those properties, but the way with RFC 9420 stands, that's the case.
So I guess in terms of a concrete outcome here, Benjamin, are you getting a sense of how we could try to craft this text, and I can work with you to try to figure out how we can come up with a couple of words that we think will scoot through here?
Sure, I think that's the right thing to do.
Yeah, I mean, so my summary is like it's the morally correct thing to do. There's just some trade-offs, and we just have to figure out how to make it sound like we're not saying must really kind of out of sort of maybe.
We definitely don't want to be able to say, Mimi is not following that recommendation, so it's a bad thing. Like that's what we want to avoid, right? If we can just like phrase it so that we avoid that, that's fine.
Okay, cool. I forgot to ask for a minute taker at the top of the hour, so I've taken some notes up to now. Does anybody else want to volunteer to take over?
I can do that.
Awesome. Thanks, Brendan. There is a note-taking tool somewhere in here. Where the hell is it? I don't know where it went. Oh, there used to be a place where you could like.
I found it. It's at the top.
Awesome. Thanks. Oh, it's under my stop sharing button. Cool. All right. So the only other thing that's going on is this list of things that I think Rowan very nicely went through, and because there was a lot of comments and kind of tick through these. So Benjamin, I think we just kind of have to go through and make sure that we address all these. Yeah, I went through quickly, and the CRL light text got dropped, so we don't have to have a reference. The MixNet thing, I'm sure there's a reference out there. I was lazy and went to Wikipedia and just grab the first reference that looked good. You might know more.
I mean, Ecker actually think it should be dropped, and I'm kind of inclined to say so too. I mean,
yeah, so that's one of those.
Not specific. We don't necessarily need it. Like if you want, we split the transport from the rest of the protocol. If you need the transport that actually provides you stronger like strong security guarantees or strong privacy guarantees, just use that transport.
Right. And I guess the only other thing I want to highlight here is, which you may have read, I don't know that everybody else did, is that we had some comments, and I think there are some changes that we are not going to make even after the question or the comment they made, right? So, Rowan, that was your point about answering, putting the A colon, right? Yeah, so it's like we're not going to make, so there's a couple in there where it's like, like use recommendation instead of 2019, like it was a question, and we're like, it's an informational document. We're not trying to make it 2119 because that puts us in a whole nother, problem. So we're just going to leave this alone. So if you can tick through those, that'd be great. And I don't want to put too much pressure on you, but the sooner you can get that done, the better, because then we can actually progress this document. Because I think we're pinned on doing the charter until we get this done.
That's addressed to Benjamin, or what were you talking to me about?
I think it's Benjamin, but since you volunteered and stuck your nose out there and we're double checking, let's make sure we get it up.
Like this context, like I just totally forgot everything that I knew about this list of things. So
I'll under that. Anyway, there is a full editorial pass to take on top of it. The thing to make sure of is that I don't change too much of the content. I actually show that there is a pull request that you can open, Sean, because I introduced a comment like when I went through the entire thing. So Rowan actually made a PR to remove a sentence that I added. We can probably discuss this in a sec. That was related to maintaining encrypted state on the servers, I think. And I said, in the future, you can actually, I know of existing use cases that use homomorphic encryption to re-encrypt the ciphertext data on the server. You feel to remove Rowan. I have use cases. I know government use cases that actually do this already. It's just not super cheap, but it works, and it's like maybe Conrad.
Do you have a reference? And is this something that you think?
Well, actually, you can ask your own government. Maybe they will answer you. That's
well.
Do we have a reference that we can put in a document?
No, but I don't think we need to, as long as it's not false. You can already do this.
In other words, what I hear you saying is the people that want to do this, they want to keep it a secret, and they already know how to do it, and they already know they want to do it.
Well, listen, I'm French.
I'm not really any use in telling them that they can do it. And for everyone else, even if they wanted to do it, there's no reference for how they would.
Honestly, I mean, it's like it's standard. Like everyone that knows FHE actually knows how to do this. Like, yeah, there is no, like you go to Zama.ai or any kind of company that does FHE, and you get code to do that. There is no novelty or strangeness. I mean, I personally don't care if we remove it or not. I think it's just like people, in my opinion, the reason why I added that is people should know that they can actually do it. That's the only reason I added that. It's fine if we don't add it.
Richard?
I was about to agree with Rowan until the very end there. Like, I would be fine dropping this. You could add some more fluff words, but crafting the fluff words doesn't seem worthwhile. Let's just drop it.
Yeah, let's just go ahead and get it out of there. So I guess for the notes, we can say we're going to merge PR 243.
Let me do that now.
Yeah. Okay, cool. All right. So I think that brings to a close the architecture discussions, unless there's any particular point, Benjamin, that you think we should further discuss.
Don't think so. I mean,
again, thanks for everybody for working through this. we're getting there slowly but surely. All right, cool. So now we're on to the extensions part of the discussion. And I think the first part of the discussion is really, let me see if I can't find that again. We have this huge list of extensions that we're going to work on. And I think we probably need to do some kind of triage as to which extensions we're going to, like, it's this list of, all of these that we're going to work on. So I think there's clearly some that are already in the extensions document that I think we've got some kind of agreement on. And then there's a bunch more that are coming. So I'm kind of curious what people's thoughts are about how we ought to triage these, because I think if we show up with 20 extensions, there's 20 of you, and there's only going to be so much energy to get these done. And so is there any way that we can try to figure out like how to work through these? Richard?
So my personal favorite is the additional credential types, mainly because I wrote it and I'm planning to ship it. So yeah, I haven't updated the draft because there's been no changes. I think it's actually pretty baked. We're actually doing some interop tests, not on the MLS part, but on the credential bits with some real live identity providers imminently. So like this is getting pretty close to like actually being useful in products, and so it seems like it would be useful to get it codified in the working group. And I think Rowan has an interest in that. I think it will ultimately be useful for Mimi as well. So yeah, I would propose we go ahead and get that adopted.
So I want to ask you, is it baked enough that, or succinct enough that it could go in the MLS extensions base document? Or do you think it's better as its own separate standalone document?
I'd be happy to talk with the authors about that. I don't really have an opinion. It's a real simple extension. And yeah, I don't think it's going to need a whole lot of additional stuff. The one thing I would worry would hold it up a little bit is it has an external dependency on OpenID for the VC format. So yeah, I'd be worried about that holding up the extensions document.
All right. So Rowan, do you have a comment on merging it in with the other document?
Yeah, I was going to say the external reference is an issue. The other question I wanted to ask is, what with the safe extensions, is do we have a good feeling about if part of this is a safe, like is the group context thing that says you can do this, is that a safe extension? Can it be a safe extension, et cetera, et cetera?
One other thing that just came up on the chat, we had an adoption call on the additional credential stuff back at IETF-MLS-20240125-1500. Can we just consider that still valid and apply it against the new charter?
Yeah, I mean, I'm not gonna, for ones that we kind of slam dunked it. I mean, okay. I think that there were, I might have to go through some, minor, like, hey, we already did this, object now, which changes the context a little bit. But for ones that we've already kind of demonstrated that there was strong support for, we're just going to adopt them. And maybe what we do for this,
So which ones does that apply to?
To be honest, I don't have that list in my head. I apologize, but I can definitely, I can recreate that list from the minutes. I guess what I'm thinking about for your document, if the concern with the dependency is, we can always leave it in its own separate document, and at the last second merge them, right? So if we're getting to the point where the actual the basic MLS extensions document is ready to roll, then we can just merge it in or leave it separate, whatever. It kind of feels like if the timing does kind of line up where it's possible to put it in one, we should have it in one, because it's one of the things that I know people complain about TLS. It's like, hey, you've got this one extension document, that's great, but then I got to go find all of them. So it is in some ways better to have them collected into one.
Yeah, I would say let's go ahead and adopt it, and I'll try and get that OpenID dependency moving. And if
yeah,
it looks like it's on a good track, then we can combine them.
I mean, technically, I can't get it. We can't adopt it until we get done with the working group for charter. But you know,
okay.
Raphael?
Yeah, I just wanted to get back to the question of the process here, because I feel we did discuss some of that previously before we rechartered. So just so that we're on the same page, what we did discuss in the past is that we have this one MLS extensions document. And in addition to that, we can have an arbitrary number of other extension documents. And in order to decide where an extension should go, we said that roughly the guidance should be that, you know, if it's small and it seems relatively useful to a number of people, it should go into the extensions document. But if it's bigger and if it's more niche in the sense that fewer people will use it, then it's probably better if it's in a separate document. And in terms of adopting it, so if it's a separate document, IETF already has a process for that. And if it goes into the MLS extensions document, then it should just be advertised on list that there is an intention to do so, and then people can still object. And if nobody objects, then it can be part of that document, as it's the case with, you know, other things you specify in documents. And so if there's no objection to that and what we discussed previously, the only question is, once we are formally rechartered, do we need to go through the process again formally of adopting stuff?
I hope not. I mean, the only reason why I haven't done it is because typically we have to confirm things on the list. So there's two ways to do that. You know, you can send out a consensus call that says, you know, disregard everything that happened in the meeting. Let me know now what you think. Or we can say, you know, there was strong support. If you object, let me know now. For this one, I think for this particular extension, I think for the safe extensions one, I think what we're going to do is we're still kind of trying to figure out where it would go because of this external dependency. So the other reason why it might not go on the MLS extensions document is because it's going to hold everything up for 3 years, right? So that's another reason why we might leave it out. So I think what the plan for this one ought to be is we recharter, I send a message to let people object if they're going to get the document in, and then later if we decide to roll it in, we can do that. Just so that it can keep kind of going on its merry way. Because I don't think the safe extensions one is going to be able to go any faster than the MLS extensions one. Like that's the one that's going to, I think, should go first, and all the other ones can follow. And so yeah, there were like 3 or 4 that we discussed. And I know Britta had one too that got discussed. That was like, yes, when you provide more information, we'll consider it. But there were 2 or 3 others, I think, that were like, yeah, okay, this sounds great. Britta?
Yeah, that one is also being worked out. So that probably falls under the common operational patterns. And that one's also being worked out with these user tree draft. I think those 2 will probably mature in parallel. They're out there, people can comment, and there is interest in moving ahead. But that falls under that category.
Awesome. Okay, so we're at the point now where I think I did everything that I wanted to do. And so now the question is, does anybody have any particular, is there some additional information that should be provided about any of the existing extensions, et cetera? All right, Bertie, you jump back in the queue again.
Fast turnaround. So there's some work going on the post-quantum side. Some folks have weighed in, like Rowan weighed in, and this goes both to the current combiners draft, but also, I would say, looking a lot further down the road. If we're talking past the 10-year mark, where we're getting serious about quantum computers and whatnot. so it'd be really great to get some of the feedback from the implementers on those. And I think there's various side chats that happen, but we can also put this to the wider mailing list if need be. But to get that moving, we really want to hear from the implementation side. So that'd be great.
All right, Conrad.
All right, can you hear me?
Yep, coming in fine.
Okay. Thanks. So yeah, we also at the end of last year sent around the virtual client stock, and if people are interested, I can talk a bit about this. I have a few slides prepared, but yeah, only if we have time, and this is something that people want to discuss now.
All right, so we definitely have time. So the question is there any raging objection? Richard?
I would listen to some slides on that.
All right, awesome. Conrad, I will stop sharing, and you can grab.
Actually, while we are building the queue, I also have some thoughts from the Mimi design team that may ultimately wash back to the MLS working group that I can share with folks.
Awesome. All right, you asked to share slides. Is there someplace?
I don't think I've ever shared slides on here, so how does this work? I've put a link to the Google Doc presentation to the chat if anyone wants to take a look there. How does this
So
work?
I think there's a share slide button, a share screen.
I tried to share slides.
Yeah, I think you've got a. Where's the buttons? Note taking, meeting material. Not there, obviously, so we put them up. All right, can you try that again? The share. You asked to share slides. I hit the X, and it's denying it. I don't know where to say yes. Awesome. I think you might have to share your screen.
Okay. 1 second.
You have. Now, why can I not
just say yes? Share screen?
Yeah, it's fine. It's saying I give this little thing, and then I don't have a way to actually say yes.
Alternatively, you could just open the Google presentation. It's just like 6 slides or something.
Oh, okay. Can you drop that in the chat, and I will open it? You did already. You already sent it. Let me get it in the right window.
In the meantime, along the post-quantum thing that Britta was bringing up, I was planning to abandon, well, it already expired, but abandon the Cypher suite that's based on Kyber and to reintroduce a new document this cycle with a Cypher suite based on the new X-Wing combiner, which is using almost the same method.
And just to be clear, that's still using X25519 and Kyber. It's just changing how they're combined, right?
X25519 and MLChem, which
MLChem,
has like one thing that you need to do different in order to combine the ciphertexts back in, because MLChem doesn't reintroduce the ciphertext, but Kyber did. So the chem needs to do that instead. So, but that document is like 2 weeks old. But I would be happy to make I was going to do a PR on that document to make sure that it IANA registers to fix the IANA registry, and then like just reference that in the same way that I did in the other document. So if anybody thinks that is a bad idea, please speak now.
I mean, I guess the only question I have is how long do we have to let it gestate in the CFRG before we just adopt it and run off?
I mean, it would be nice if it were a draft IRTF first.
Yeah. Nick, you got some input?
Yeah, I can speak to this. We're still kind of deciding. I've been consulting with some of the other chairs about what the path forward is for CFRG, determining things with respect to hybrid chems. we're leaning towards the idea of opening 2 calls for adoption, one for generic combiners as a CFRG like informational document. Here's how you do combiners, and there's a draft for that from Mike Onsworth. And beyond that, there may be the opportunity to do a specification of a single hybrid cam, whether that's X-Wing or whether that's one of the other. There was another hybrid cam that was submitted within the last few weeks. That's something that the CFRG is going to put up. So if you have an opinion about this, keep your eye on the list for feedback as to what the CFRG should do.
Okay, thanks.
Okay, over to you, Conrad. I'll draw the slides. Let me know when you want me to move up and down.
Okay, cool. Thanks. Yeah, so this is joint work with Joel, Britta, Marta, and Raphael. And yeah, you can just, next slide. So what are virtual clients? Virtual clients is this concept that's been floating around for a while in the MLS working group before I joined, at the very least. And that's essentially you can think of it having a tree, and then under an individual leaf, you have another little tree. And this kind of little tree is hidden to some regard from the rest of the tree. And so when we thought about it a bit, and how we kind of decided would be a way to do this kind of subgroup thing where you had a group underneath a group, would be where a bunch of clients, which you call emulator clients, cooperate using an MLS group in kind of emulating a virtual MLS client. So these emulator clients all hold the state of the client that's in the actual MLS group, in the kind of higher level MLS group, and then they can jointly operate as that client. I just want to note this is like not a threshold thing where you need like X number of clients to do something with a higher level client, although that might be interesting too, but that's not something we thought about too much. Okay, next slide, please. Yeah, so, oh, did I mess up the order there? Oh, the slide is missing. Did I delete that slide? Yeah. Sorry, I just re-edited a slide. Can you go back one slide? There's a nice graphic that might make things a bit easier. Yeah, okay. Thanks. Don't know how that got lost. Anyway, so yeah, this is essentially how it works. You have, for example, you could use a virtual client to do a kind of user abstraction in MLS, where you have Alice, Bob, Charlie, and Dave, and then kind of Dave's leaf represents Dave's, but it's not an actual kind of MLS client running on a single device, but instead it's kind of jointly run by kind of an MLS client running on Dave's phone and an MLS client running on Dave's PC, and they both hold the state for this the root essentially on this little tree on the right, and this state is used to act as the leaf in this kind of higher level group that's the group on the left side essentially. And so it allows you to have these kind of hierarchical structures. So this is just an example. You could also have a hierarchy where you have an organization, and then you have all the departments in the tree, and underneath the departments, there are individual groups that hold all the members of the departments, and MLS trees all the way down, essentially, if you want to. Yeah, next slide, please. And then going a bit more into detail. Yes, so it might be a bit complicated, but MLS helps us get there, I think. And so we call these kind of clients that collaborate in emulating a virtual client, call these emulator clients, and they have a group which they use to kind of manage the randomness of the virtual client. For example, if the virtual client wants to do an update, or an emulator client wants to have the virtual client do an update, then they derive the randomness for the update from the group that they use to emulate the virtual client. And then everyone in that group has access to that randomness. And then they also, as Richard says this is complicated to pull off, but MLS kind of helps us because we can use the emulator clients can use commits to coordinate on the actions of the virtual clients. And by virtue of the kind of commit ordering, they agree on the sequence of actions of the virtual client. Yeah.
Yeah, it seems like the main thing, just to confirm that I'm understanding the operational picture here, it seems like this, in addition to the ordering requirement in the big group, you have ordering requirement in the big group, you have ordering requirement in the small group, and then they're actually kind of coupled because when a client in the small group does a commit, they want to do a commit in the small group that produces the new leaf for the commit in the larger group. And so this client needs to basically have the lock on both groups, and both of those commits need to succeed in order for the whole thing to work.
Kind of. It depends. That's one way of doing it, but you can also, if you want to get the performance requirements, I think that's on the next slide. If you just want to go ahead with the next slide. Thank you. It is kind of why are we doing this in the first place? And one of the reasons could be a performance increase where you have one kind of coordination group, and this coordination group or emulator group emulates virtual clients in a bunch of MLS groups. And then you don't want to do one update in the emulator group every time you do an update in each of the single one of the higher level groups. And instead you do just one update, and then you feed off the randomness in that update for updates in the higher level groups, even if they're kind of course, kind of slightly apart, temporarily speaking. So you kind of lose a bit on the PCS, FS gets a bit wobbly depending on how you export the randomness. But it's a trade-off, right? Because you only have to do kind of one update in the small group, and then you kind of get to use that X number of times depending on how many higher level groups you have. And you can, and this kind of compounds, if everyone does this, then groups, kind of globally speaking, groups have just fewer members, and you do updates generally get cheaper because you have this mass effect of kind of one update in the smaller groups being able to feed lots of updates in the bigger groups. And this is especially interesting if you have algorithms or kind of circumstances that make big groups expensive, such as PQ cipher suites, or we had a design for, I think, for deniability at some point where you had to do a lot of updates, and that of course becomes much more feasible if the updates are not super expensive. And also kind of one nice thing that you can do, but you don't have to, is you can hide metadata. So if you, if we go back to the example with Dave having 2 clients, then other users would only see, oh, this message came from Dave, but they won't know if it was Dave's phone or Dave's PC. And yeah, that can be nice in certain circumstances, and others it's maybe not desirable because you want to know exactly, and then you have to figure out how you do the AS and how you manage the key material there. So this is just the rough kind of draft and the rough ideas that we came up with initially. There's, of course, as you can see, there's lots of kind of room in many directions. And now we're interested to see what everyone else thinks, what people might want to use this for, and yeah, what direction people will want to go with this. We have a few more ideas, I think, but at this point, we're opening up to everyone essentially.
Just another quick, how does this actually work question. I can kind of see how this works for the asymmetric secrets that are relatively slow to change. But how would this work for actually sending messages for the the secret tree? It seems like you have a nonce for use problem.
That's a good point. That's kind of a thing that we worked a bit on, and until Joel had a really good idea with where we, and this is kind of what makes it potentially kind of an unsafe extension. Or at least the hope initially was to make this completely transparent, and then kind of so that no one in the higher level group would actually, you can just run vanilla MLS, and no one in the higher level group would actually know if someone's operating a virtual client. But this doesn't quite work because, of course, if one of the kind of emulator clients sends an application message, then that secret is burned. And then if someone else sends kind of another message with the same secret, you kind of cross the streams there, that's not great, because then you get decryption errors, and we don't want that. And so what you do is you have a different secret tree design, where at the leaves of the secret trees you have kind of a punctuable PRF, where the client who sends the application message sends along a challenge that you, or kind of a secret value, or sorry, not a secret value, an actual challenge that you use with the PPRF to derive the secret nonce pair. So there's more information on this in the draft, but you're right that this is not super straightforward. And but on the one hand, it's not super straightforward. On the other hand, we have a solution, albeit one that's not vanilla MLS compatible.
Yes, so I have a question from the perspective of the platforms that are actually going to hold the keys in a lot of scenarios. In a normal scenario, we would basically keep the asymmetric keys and the encryption keys in the platform for the application, so that the service provider actually doesn't have access to those keys. But here you are basically proposing that clients have to build a shared secret that's outside any secure enclave or any hardware or any protection mechanism, because you have to be able to build it across device. And so basically you are, I think it actually will be very negative on the actual security of the keys that people would expect from an MLS session, where, you know, one client has its keys in the platform, it's in hardware, it's in DOS or whatever, but it's not the application that holds those keys. And in some sense here, you have to export things in outside of the platform so that you can do the magic to synchronize everything. So I have a bit of concern here on just put MLS on the secure enclave, says Richard. You know, like, keep in mind that I have like strong, you know, like, doesn't feel amazing in terms of key storage and, you know, actual level of security that you get. But yeah, just a thought like that. Maybe we can find a way to actually mitigate that. That would be good. But as a first thought, this seems like pretty difficult to handle.
Yeah. So it's a bit ambitious, the whole thing. And then I'm not sure if it's going to work out and be practical in the end, but we're optimistic. With regard to this key sharing stuff, I mean, keep in mind that we're not sending around key material, right? Everyone just derives the keys locally, just like you would an MLS exporter key in any other group. What you might run into, though, is where you have to, depending on what your AS looks like, you might have to derive the signature key of the virtual client. And if that is supported by your secure element, I don't know. So yeah, these are all things we have to figure out. Fair points. But yeah, if you want to write a section, sorry, Benjamin, if you want to write a section on the kind of considerations we have to make in the document, then
Sure.
You're happy to see a PR.
I can help with that.
That's great, thanks. Sorry, Raphael.
Yeah, I also want to chime in on the questions from Benjamin. So I think the status quo with secure enclaves at this point is that they can hold signature keys, but not HPKE keys anyway. So those are out of scope typically. So in that sense, it doesn't really apply here. And like Conrad said, for signature keys, it's still a question how the AS works in that instance. And it's not something that the virtual client document will, specify, in the sense that there won't be just a single solution here. If
Raphael,
it is,
repeat that, but you said at the very beginning, please, that you can have what, but not, you can have what kind of keys, but not the other signature keys.
So HPKE keys, like the chem part, is typically not supported by secure enclaves at this point. So the understanding is that they will hold signature keys, if anything. And so in that sense, it's not a concern, since secure enclaves cannot cater to that anyway. And for signature keys, it depends on what the application chooses to do for the AS. It's still like, if you really want to use a secure enclave for signatures, then you can still do that. It's not prohibitive in that sense. But in the past, I've been part of discussions where it's also not practical to use secure enclaves. Richard just says, okay, that Apple now appears to support HPK. Okay, that's cool. That's new apparently. So, but the question here is whether you only store long-term signature keys, also short-term signature keys in secure enclaves, because accessing that, at least on Apple, requires to actually have biometric authentication, which then again prevents apps from styling stuff when they're in the background, etc. So there's a bunch of considerations there to look into. But again, virtual clients are not necessarily prohibitive of that. And yeah, so, but yeah, why I raised my hand in the first place is that what I feel needs to be repeated here is that virtual clients, this can be a brutally, brutal gain of efficiency, depending on what the architecture looks like. So this is really the biggest win here is efficiency. If you consider like messaging services that allow, say, up to 8 or 10 devices, you can hide all of those behind one leaf. That makes a huge difference.
Did anybody want to comment on Raphael's thing, or am I okay? Yeah. So on the efficiency side as well, like if you have like 2 different organizations or a handful of different organizations that have a chat with a lot of people, like this often happens in financial trading, that there the efficiency can be even larger, because you could have one, like a small brokerage house or something like that with a handful of users, and they're dealing with, in a group that might have hundreds or thousands of users from other organizations. And so you can, like, breaking the hierarchy up so that each organization is at the top level only has a single leaf. Like, that's actually an even bigger efficiency gain. So that's pretty tremendous. That would be quite useful.
What would be very useful is to have like an assessment of the impact on FS and PCS windows for the overall epoch secrets. I anticipate that basically it's not going to change much, except that the windows will sort of expand because you have like a bunch of clients. It would be good to have like this kind of, but I mean, it's interesting overall. Maybe we can actually build something that's super nice and secure with that. So
yeah, maybe one more word on that. We can get pretty tight forward secrecy when we're using PPRF exporter, as Joel proposed at some point. So all the secrets we export for the virtual client actually forward secure at that point. And then the only thing that suffers is post-compromise security, because of course, if you kind of reuse a secret from kind of an update you did in the small group kind of earlier on, then you're not getting true post-compromise security in the higher level group. You only get the same that you got in the smaller group, essentially. So yeah, it should be pretty straightforward, but that's definitely a section we should include. Agreed.
So a small addition to that, that's true. So if anything, like per group, PCS becomes potentially worse at first. However, it really depends on what your initial policy is for issuing updates. So now that the groups are much smaller and things are a lot cheaper to do, you can actually increase the frequency with which you do PCS. So what looks like a loss at first can actually be a gain depending on how aggressive you are. So it's kind of hard to say, you know, this is going to make it better or worse. It really depends on a lot of parameters in that sense. Yeah.
If there's no one else, there's one last slide that I forgot conveniently called limitations, because there are, of course, the limitations that we already discussed, and then there are two a bit more subtle ones. Is that it gets hard for external or kind of it becomes hard for someone who's not in an emulator group to remove a member of the emulator group, because even if you remove that person from the emulator group, it still holds all the secrets for all the virtual clients. So that needs some more thought, although there are possibilities, like you could publish key packages for which only a subset of the emulator group holds the secrets. And there's a few workaround ideas, but that's something we maybe even need to live with, and maybe we can crack, but that's at least a limitation. And then external joining by new clients. So if Dave gets a new, I don't know, an additional phone or something, this is a bit harder because the phone can join the emulator group, but it doesn't automatically get all the secrets from the higher level kind of virtual clients groups. And either an existing client provides it with that stuff, or it does an external join in all of the virtual client groups, which might be okay, because in the kind of the natural setting where each client is an individual leaf, it would have to do that anyway, or it would have done that anyway. So the performance would probably be roughly the same. But yeah, those are kind of the limitations that we stumbled upon, but I'm sure there's more to discover once this gets closer to, people start thinking about it more in their respective use cases. And I think that's all I had on this.
Well, from my perspective, I think actually this looks kind of interesting. And really the way that this is supposed to go is you bring stuff that's not fully baked, and then we bash on it, and we find things that are either good or bad, and we iterate on it. So I think it's all good. Richard?
Yeah, no, I was just going to plus one that. Is there a draft in this yet, Conrad?
There is a draft. Let me find the link.
Okay. Yeah, I think this seems compelling enough that reading a draft would be interesting. Not totally sure it feels baked enough to do any adoption yet, but yeah.
No, I wouldn't be super confident on the adoption, but maybe, if people have time to read until the, I don't know, IETF-119, I'm not sure if that's too close for adoption, but yeah. I put the GitHub repo link in the chat.
Yeah, and in terms of whether we could adopt it by, if people think it's like baked enough, could we do it by Brisbane, which is in March? Yes, we need 2 weeks is really the kind of time that we need to run the adoption call. But it's probably not a burning need that we really have to get it before Brisbane, because we're gonna, again, I requested 2 hours. We should have some time at the end if we want to bring this back up and talk about it, if you have time to update it in the meantime. So, all right. Anybody else on this particular issue or draft? All right, Conrad, thanks. Okay. Raphael, before we get too far, do you want to say anything about the generic MLS extensions draft or safe extensions, or anything about the ones that have already been adopted? Thanks.
Yeah, there hasn't been any activity on any of that actually in the past weeks and months. So unless there are some questions, I actually have nothing to report at this point.
Okay, great. Thanks. Richard.
All right, let's see if we can share a screen here. So this is going to be some brand new stuff. So if folks are aware that MIMI is a working group that is planning to use MLS. And so the MIMI as a design team has been trying to come up with an initial protocol that the working group can adopt. So they've been thinking about how to use MLS for this generic interoperable messaging protocol.
Well, hold on, Richard. Nick, is it me, or is it because I don't have a way to like say, yeah, you can share the screen? Is there some way? Because I can't like approve it. I don't see any place where I can approve it.
Oh,
okay, there we go. Yep.
No. I saw a new screen share is being started, but then it disappeared.
Yeah, I attempted it. It seems to work.
Okay. Interesting. So you give it a shot, and I think it should just let you do it, because there's no way for me to accept it.
It does not appear to be letting me share. So what I'm going to do is I'm just going to do what Conrad did and drop a link in the chat to a little piece of text that Rowan and I wrote. So the thing that Mimi is trying to do is, run an MLS group alongside a messaging group that sets up the keys for confidentiality for that group that provide end-to-end protection, encryption, confidentiality protection in the face of the Mimi servers, and also synchronizes some information about the state of the group. Now I realize this needs a new name that doesn't have such an awful acronym, but the idea is that the Mimi charter forbids them from developing extensions to MLS. So whatever the bits are that Mimi needs to synchronize their app state will need to wash back to MLS. So this is just like a super sketchy first pass at what that synchronization primitive would look like. Basically, the idea is that you have an extension sitting on the group context that reflects the current agreed state of the group. Again, in whatever form you'd like to imagine that, that's something we can discuss. You can imagine just hashing some state object. You can imagine having something more literal. And then, so you have a group of context extension that captures the current agreed state. And then there's a proposal type that reflects updates to this application state. And again, the format of the updates is something about which we can have reasonable disagreements. In fact, Rowan and I were working on this, and we have pretty strong disagreement about whether the state updates should be opaque or whether they should have some structure that the MLS implementation could handle or whatever. But in any case, the idea is that you basically tunnel the application state updates through MLS so that you can, by virtue of the group context extension, the app state being reflected there, that gets fed into the key schedule, so the whole MLS group agrees on the application level state. And then handing things around in updates in either private messages or public messages, as we discussed earlier, means that that provides authenticity and or confidentiality protection as those updates are getting sent around, and having them as proposals makes sure that the clients processing the updates and agreeing on the updated application state have gotten those updates before they confirm agreement using the MLS key schedule. So yeah, that's the idea here. Rowan, did you have any further thoughts on that? Did I miss anything?
Yeah, I would just say from in terms of trying to make this concept simple, the AppSync proposal type allows you to say there's a registry of applications of application state blobs. And you can, unlike the group context extensions proposal, you can manipulate any one of these blobs independently and still get agreement. And this doesn't need to, and because it's an application state thing, it's a thing which is presented up to the, if you're writing an MLS stack, that you present to the upper level, to the application. And it's basically, it could be treated as opaque or as like some kind of a struct that isn't interpreted by the MLS stack. So the only disagreement that Richard and I had was whether we also want the ability to be able to have some struct, some structure to these individual application state objects. And so what is in there is basically, well, you know, there's some common patterns of having maps and arrays. And so being able to manipulate those individually could potentially, in very large groups, it could prevent you from having very large updates of any of these items. And in the Mimi case, that was potentially interesting. If I have to go and modify the entire participant list for a group of 10,000 users, that's a big update. Whereas if all I want to do is just remove a single entry in an array, that's a much smaller operation.
Thanks. And yeah, just to again remind people of the status of this. This is like not even totally agreed among the Mimi design team, much less the Mimi working group. This is just presenting an early warning of some ideas that might wash back into an ID if the Mimi working group starts to head in this direction. Or, if folks think this is generically useful, we can certainly, tune it up and bring it over here for other non-Mimi reasons. Conrad?
I have a question. So this application ID, UN32, is that meant to be IANA registry control? Because otherwise it's going to be complicated.
Yeah, something like that. There needs to be some way to manage those. The idea of the application ID is just that you can potentially run multiple different types of application state on top of a single MLS group. And yeah, you would have something like an IANA registry to deconflict those.
And then kind of follow-up question, as long as there's no one on the line. In terms of kind of layers of abstraction, so one immediate kind of advantage of this that I see is if you implement it, you can implement this and you can have a nice kind of API for this extension, and everyone calling your stack, you don't have to implement your own proposals. Like even if you use the safe extension interface, you would still have to kind of implement the semantics of how you want to modify the state that you have. So this makes it really easy makes it really nice from an API standpoint of an implementation. At the same time, so there's kind of application ID. So this kind of looks a little bit like the safe extension draft, this kind of generic extension. So I guess what I'm trying to say is there's some overlap, and I'm just trying to figure out how we can merge these, or if it makes sense to merge these in a way that makes sense. But yeah, we can talk about that offline maybe. And I guess what I'm trying to figure out is when would you register an application ID and when would you register an extension ID, and kind of what makes more sense.
Yeah.
Yeah. So Conrad, I think you would register a regular safe extension when you wanted to when you wanted an extension that was modifying the behavior of MLS as opposed to just providing agreement on something that's at the higher level. Does that make sense?
That does make sense, although you can also have an extension. So I guess what this does is that it's a really generic way of allowing applications to just have some state in MLS and agree on some state. I think that was the main intention there, right?
Yeah.
And then you can still have an extension if you want. well, I guess it doesn't really have to be an extension. If you have proposals, if you just want to signal operations regardless of any state, you could register individual proposals or register an extension and then have extension proposals under that extension. But yeah, anyway, I think this is a really useful mechanism, and yeah, I'm just curious how it interacts with the safe extension stuff.
You know, I agree. We need to work out the answer to that question. I mean, it should be safe because it's just touching. It's not touching MLS at all. It's just handling application stuff. But yeah, we should definitely do that deconfliction. All right, that's all I had on this.
All right. Rowan, you were the other person who was fast and furiously generating extensions. Which, if any, are still a going concern? We heard about the PQ switch, so I think we can kind of go past that one.
Yeah, so looking at the list of the presentation that I did at 118, so kind of going backwards, I abandoned group anchors. That's still abandoned. We don't need that. The X25519 Kyber draft, I was planning to replace that with one that uses X-Wing instead. Extensions for Mimi, basically, like, we wouldn't need to do, basically we would just use what Richard described. And then the last two are self-remove and this MLS key package context. So for self-remove, I think we could go forward with this, but it seems that in the process of going through all of the things that we are, the use cases in Mimi, I keep coming up with this condition that I think we want, which is, instead of assuming that external commits don't have access to pending proposals, that maybe we should have made the opposite decision, which is that, or we should have a way to switch that behavior. And so maybe instead, like, we wouldn't have needed self-remove if we had a way to ensure that external proposals always had access to all pending valid proposals. So if an external commit just goes and says, give me the group info, and by the way, give me the list of all the pending proposals according to the hub provider, or the whatever the DS can provide. Like, here's a group info, here's a ratchet tree, here's a stack of pending proposals, and then you can generate a commit with all that stuff and commit it, and Bob's your uncle. That seems actually like a lot more elegant than, like, we wouldn't need the self-remove proposal if we had that. And it allows for a bunch of other things that could potentially get externally proposed, like AppSync proposals to change the state of to change what users are allowed to do what in a Mimi room. Does anybody want to comment on that at all?
Nobody's jumping in the queue.
Okay, so what I'm probably going to do is I'll probably refresh self-remove so it's not dead, but I'll probably also go and write another draft kind of proposing this. And if anybody is interested in collaborating on that and has an opinion about how that should be done, or please let me know.
Right, Conrad?
I just want to say that this is a thing certainly worth doing, and if you need any help, feel free to ping me.
Okay, thanks. Okay, and then so then the last,
jumped in there too.
Oh yeah. Hey, Brendan.
Hey, I was going to ask if you have thoughts on how or if this would work with encrypted proposals.
So let's say that, so if you were using encrypted proposals, would you ever use external commits? And if so, is presumably if you were using external commits in this kind of distributed group, the only requirement is that wherever you got your group info, you also get your stack of pending proposals. So if those are both coming from the same leaf node, then it seems like that would still work. So I think it depends on how you decide like how the synchronization works. So like in a distributed environment, if somebody sends out a proposal and as a commit is being sent and they cross on the wire, and this one, the commit has pending proposals 1, 2, and 3, and proposal 4 was sent. How do you decide which one is valid? I don't know, but that seems like that there's not really any particular problem with the idea of getting a stack of valid pending proposals as an external committer.
Okay, I'm not sure that this would work. I'm not immediately sure that this would work in a decentralized environment because it sounds like you need a really strong consistency guarantee that you have somewhere that knows all of the proposals that have been sent, which you wouldn't necessarily have if you're decentralized. But I definitely think this does sound like a good idea in a centralized environment where you do have that, because you, basically because of the improvements that you said, I think are worth it.
Okay, so if I can recap, it sounds like if you're in a centralized environment, this makes sense. If you are in a decentralized environment with no strong notion of consistency, then this doesn't make sense. And potentially, if you were in a distributed environment that did have some strong external notion of consistency, it might make sense.
Exactly, yeah.
Okay. Okay, anybody else want to say anything about this particular topic here? Okay, and then the last thing that I had here is this key package context, and I haven't really thought about this in a little bit. And Brendan made some arguments for why he thought this should be done at the application layer, and I think I still need to go off and think about that and reflect on whether that makes sense or not to me, and either drop it or come up with some additional arguments why I think it's important. So.
Okay. Great. At this point, I'm willing to throw it open to anybody else that has anything related that they'd like to talk about. Okay. Britta.
We can discuss a little bit on the post-quantum side. I believe Susan might have a slide or two to share, and
awesome.
Get some feedback from everyone about options there. If that works.
That works great. We got 36 minutes.
Susan, over to you.
And we're back into how do you make... So I see you there, but I don't know how to make you share slides.
Or share my screen.
Yeah, I think you got to share your screen, unfortunately. Just make sure we can't say anything important behind it.
Okay. Can you see my screen or?
At this point, no, unfortunately.
I will post the slides.
Yeah, apologies. I suspect this is probably my fault.
No, no worries.
I think you need to provide access to us. I think you have to change the sharing permissions to anybody with the link.
Oh yeah, sorry about that.
No worries. I do it all the time.
I literally just made these slides.
Well, that's good. Nothing like on the fly.
Share, publish to web. Does that work? Oh, there we go. Screen share is being started. Oh, that's for you. Okay. All right. I guess I'll let you disc jockey this. Yeah. So we are doing some parallel work to the hybrid Cypher Suite PQ work. We're trying to specifically tackle MLS combiners that have a little bit more flexibility, that go a little bit beyond the harvest now, decrypt later attack model. So we're focused on getting the post-quantum security without always paying the post-quantum price per message. And we have two combiners that tackle this. And also, one of the other added benefits is that there's some extensibility for these types of combiners that allow you to combine non-MLS secure group messengers, and allows for piggybacking off of a large supergroup, a post-quantum MLS supergroup with smaller subgroups within an organization. So we thought this might be interesting to share to everyone and get folks' opinions and feedback on how feasible this might be to deploy, and any kind of challenges that you may see in this in deploying something like these. So, all right. So next slide. So the first combiner is using is what we call a key management session combiner, but you basically have two groups, which may or may not use MLS actually, but we assume that at least one of them is using MLS for the sake of this example. And basically a sender samples a random AEAD key in one session, sends the key in that session, and then sends the ciphertext, which is the encryption of the key in the message, in group 2. And then to decrypt, you would only users who are in both groups would be able to decrypt the message. So this is our kind of AEAD combiner, or key management session combiner example. And then our second example is on the next slide. It's the exporter combiner. This one is basically using classical and post-quantum MLS sessions together to allow you to have what we call full commits or partial commits, where in order to do a full commit, you take the exporter key from one session and commit it in the other session, and then take that exported key to the post-quantum session again, and then commit it again, so that these two sessions are essentially glued together in this way with using both exporter keys from the two sessions. And the idea here is to use the classical session to do all of your commits and updates, which we call the partial partial commit or partial update. That way, you're not paying the post-quantum price each time you're doing a commit or update. So these are kind of high-level overviews of the two different kinds of combiners that we had. And I can go into more detail about the various pros and cons of each. But maybe that's enough for now for people to kind of just digest a little.
All right, we got a queue. We got Britta and then Richard.
So I just want to throw in a little bit more context behind the motivation. Right now we have effort in the working group towards a hybrid combiner, like, for example, X-Wing, and what that could be. And that's a good, like, immediate solution, that something readily available. We're concerned about post-quantum and harvestality and all that. But what our group has been working on is how to look a little bit more strategically long-term. And there's two sides to that. One is where basically post-quantum authentication is a concern as well. That's one part. And the other part that's probably even a little bit more interesting to the group here is about efficiency. So with a hybrid combiner like X-Wing, your post-quantum updates and your standard updates are intrinsically tied together, and they have to happen at the same time. And of course, there's a post-quantum cost to all that. And what some of these ideas are getting at is how to be a little bit more flexible in that. So decoupling those two things. So for example, in the exporter version, if you had a post-quantum group, with post-quantum updates, you don't necessarily need that same frequency of an update. It could be a much longer epoch, but you are basically bootstrapping that into getting all these standard updates that are maybe much more frequent. And that saves you lots of costs. So these are the sorts of trade-offs that we're looking at. And of course, when we talk about that post-quantum update, it could happen at any frequency. So for example, that post-quantum group might happen once. Maybe you have one update. If you have a very, not much security risk overhead, you could do that at the initialization of the session and not update again, or potentially ever, or at least for a very long frequency. But you might still be able to get some pretty strong guarantees in your regular standard session because of that inject. So these are the sorts of combinations that we're looking at, how to balance all these different guarantees, and kind of planning for that, beyond 5 years, into 10 years, how to be more modular in this approach, so that we could have one way to say, here's how to do post-quantum, and it would work no matter if an implementation is concerned or not really concerned about quantum threat, or is much more concerned, so they could just increase frequency, for example. So that's on the high level goal, and I'll turn it over to Richard for next in the queue.
Yeah, thanks for that extra context, Brett. It inspired several more questions than the ones I started with. So thanks for the overview, Shisen. I just wanted to kind of read back these two options. Starting in to make sure I understand. I just want on the exporter one you have on the screen. Okay, well, I'll start with this one. So this one, it sounds like the combination is basically done at message time by passing keys as messages are sent. Is that right?
That's right, yeah.
Okay. Yeah, and the other one, it sounds like you're exporting keys, exporting PSKs from one group and injecting them into the key schedule of the other group.
That's right.
Yeah. So that latter approach seems a lot more natural to me. I'm happy to write this up in email to you as well. This seems a lot, you're attacking the problem at a higher level. So you're hitting it at the key schedule level, so it flows out through all of the message keys, all the exported keys as well. It seems like a more systematic solution to me than doing out at the edges of the system. So that's my initial reaction, at least. I think I need to read your pros and cons list, or if you'd like to go through them here. Anyway, that's the initial reaction. I wonder, so Britta was talking about authenticity. It's kind of interesting here that, like, if you're authenticating it in the PQ Chem group, like, maybe I wonder, like, do you need authentication in the classical group at all? Right? Or have you basically, already done the secure authentication? You can just leave that be. So I think it's kind of an interesting general property that you may actually have lower requirements on the classical group once you set up the PQ group. But I think that kind of highlights a general point that if we're going to do some work on this, we'll need to be kind of clear on what the classical group is buying you here. Right? If you assume a quantum attacker that can compromise all the keys in the classical space, then all of if you want to take an extreme position, it's arguable that all of the work you're doing to make this classical group go is not really buying you anything, because it can all be undone by a quantum attacker, and you're stuck relying on the entropy that you got from the PQ group. Now, maybe the argument is that you're not. That is your posture with regard to a quantum capable attacker, and you still get better properties with regard to a classical attacker. I just think if we're going to do something here, we need to kind of crisp story on what the properties are we're getting. Last comment I'll throw in there is that this might be a good thing to kind of combine with a draft on the PQ cipher suite. I think the PQ cipher, the hybrid cipher suite is a small enough piece of work. This is a fairly small piece of work, especially if we do the combiner approach. Seems pretty simple. I think it would probably make sense to have an overall kind of how you do PQ migration draft as opposed to smaller individual drafts. So that's a bunch of stuff, but hopefully some of that's helpful.
Yeah, thank you.
Yeah, really nice work. Thank you. Just a small comment on practical aspects. So I think it would be interesting to think about the engineering requirements here. One of the risks is obviously when you have two groups is that for some reason they're not entirely synchronized on some of the clients, which is bad. And I was wondering if you have thought about some simple mechanisms like having a common framing format to have these full commits, so that they always go together, so that for applications you end up treating this as a bit of a black box, where essentially you have an API that is very similar to the standard MLS API, and you don't really care how stuff works inside. The only difference you see is that messages are going to be larger and compute is probably going to be a bit slower. But that's pretty much it. I think it would be nice to have that level of abstraction ultimately.
Definitely the engineering feedback like that is stuff that we're looking for at this stage. So that is really good. I'll throw out another possible use case just as an idea to get people's brains turning on this, and can also respond more on the mailing list. But something that we discussed is that if you are having the post-quantum group, essentially you're getting, you probably not say your average Joe attacking you, at least for some time, right? You're talking probably maybe an outsider threat to your organization. So for example, you could use this where you may have, say, a post-quantum group that, if it's a small organization, or maybe if it's large, it's for your department, and it has all the members of your department in that post-quantum group. And then for all the side chats among and all these subgroups of your department that are doing all sorts of different other discussions and have their respective MLS groups, they can use this serve as a key pool, a post-quantum key pool to, say, inject key material into for hardening, providing post-quantum hardening. And in that case, you actually probably don't need to have any synchronization between those two groups. And of course, this kind of goes back to the question of the attacker model of refining exactly, and again, long term, looking that we make a solution that can actually hold up to a change over time that will meet the different use case concerns, as well as engineering and providing efficiency. So just wanted to throw out that possible use and see what people think, and if it would be interesting, or if it doesn't satisfy some security considerations. And this can always be taken to the mailing list too, for as ideas come up over time.
All right, Richard, I see you still in the queue. Is that residual? Yep. All right. Well, we seem to have drained the queue at this point. Okay. Thank you very much for that. I snagged the link. We'll make sure to put this in the minutes so people can check this out, and definitely make sure to forward anything to the mailing list so we can continue the discussion, because it looks like there's something here. David.
Yes, can you hear me?
Yes, we can.
Okay, so I sent a message through the MLS mailing list a couple of days ago. I don't know if you had an opportunity to read it. It was about the verifiable credentials in MLS, and I wanted to, well, I don't have a presentation or anything, but to briefly talk about my idea and see and listen to your opinion about if it would be of interest of the group. My idea was to create some kind of attribute-based MLS in which you could authenticate to the group by presenting attributes instead of your identity. And we believe it would be useful in some kind of decentralized setting, and seeing a lot of work of MLS targeting that kind of environment. I thought it could be of interest to the group. I don't know about your opinions in that kind of authentication model for distributed settings.
Anybody got some initial thoughts? Conrad?
Yeah, sorry. Sounds interesting, but I have to admit I didn't quite understand the use case. So could you maybe give a kind of practical use case where, or even how it would work if?
Yes,
kind of attribute-based encryption, but yeah, sorry, go ahead.
So the idea is mainly in the authentication method, instead of using digital certificates or anything that can be linked to the user's identity, to access groups based on attributes. That means, for example, having some kind of university degree, and so in a decentralized setting, some MLS group could publish information about what attributes are required to access that group. And in that sense, users could authenticate to the group by presenting exactly the amount of attributes required to access it, such that instead of using their identity, it would be more privacy preserving. I don't know if I'm making myself clear, but
yeah, no, that was useful. It was just that. So would it be that I'm in such a group and then I get a message and then I can only authenticate that the sender had some sort of one certain attribute?
The idea is, imagine a MLS group that only people with a specific university degree can access. And you could present a credential proving you have that specific university degree, but without revealing any other information about you. So group messaging could be established in a low in a high privacy setting.
So what you're but who would verify the attribute? Would it be the other group members, or is this more
Yes,
of an access control thing?
Every other group member, like in standard MLS, the idea I devised was through users could join through external joins, and every other user would verify that attribute credential.
I see. Thank you.
Okay. If you have any opinions about that, you can ask me or send through the MLS mailing list at another moment. And thank you.
So David, I'll send you some messages off list about
Okay.
how to pull together the idea via an internet draft to get you sucked in, because that's a lot of the ways that people really want to see things presented, and so then they can review them. And I can also provide a little insight into how to participate remotely in our upcoming meeting in Brisbane, which is in March.
Okay, thank you.
All right. We got about 15 more minutes. Does anybody else have anything that they would like to add? All right. Well, from the chairs, Nick and I want to thank you for participating. We got some action items, so we'll try to get the charter done. We'll get the architecture document finished off here in the next couple of weeks, hopefully, and then we'll, we'll redo the extensions work and get it all in the appropriate way, and then start marching forward. Thanks, everybody. And again, anybody who stayed up late or got up early, appreciate your time. Thanks.
Bye, everybody.